In Lesson 85, we're looking at systems of nonlinear equations. So, equations can have more than just the graph of a straight line, and some of those nonlinear equations will include conic sections, like the circle, the ellipse, and the parabola, and the hyperbola. And sometimes there's going to be more than one solution, okay? But we're still going to be using substitution or possibly elimination, or maybe both, depending on what we're given. In the first example, we have x squared plus y squared equals 9. And that would be the graph of a circle, if we chose to graph that. And the 2x minus y equals 3, that is a line. And what we're going to do to solve this is use substitution. And what I'm going to do is get the y here by itself. So negative y equals, I'm just subtracting the 2x to move it to the other side, 3 minus 2x. And then to get rid of that negative, I'm going to change their signs. So y equals, I'm going to go ahead and move that 2x in front just because I like that format better. 2x minus 3. So this is now a positive 2x and that's now a negative 3. And then what I'll do is put this in place of the y here. So I'll have x squared plus 2x minus 3 squared equals 9. Now, when I square this, if it helps, you can write that 2x minus 3 times 2x minus 3. You can write that out. There may be times when you don't want to write it out because you could go ahead and square that in your head if you needed to. But until you get to that point, write it out and then use the distributive property twice. You would use first with the 2x across and then with the negative 3 across. So we go plus 4x squared minus 6x minus 6x and then plus 9 equals 9. And then we need to get our like terms together. So this would be 5x squared minus 12x. Now with the 9s, if I subtract 9, this 9, to move it over to the other side, that ends up 0. Minus 9, minus 9, those both cancel, so this would be equal to 0. Then I would factor out my common factor, which is just x in this case. So I have x times 5x minus 12 equals 0. And I'll set each of those equal to 0 and solve for x. So we have x equals 0 as one of our solutions, and then 5x minus 12 equals 0. I would add the 12 and divide by 5, so x equals a positive 12 over 5. If you wanted to write that as a mixed number, you could, but I prefer to leave that as an improper fraction. Now what I'm going to do is put that 0 in here to get one of the y values that goes with 0, or one of the points. And then I'll put the 12 over 5 in for x and get the other point. So putting 0 in, I'll have y equals 2 times 0 minus 3. So y equals a negative 3. So for this point, it is 0, negative 3. And then I'll put this 12/5 in for the x here. So y equals 2 times 12 over 5 minus 3. Y equals 24 over 5 minus 3. Now I need a common denominator since we're working with fractions here. So that would be a 5 on bottom and then 15 on top. So 24 minus 15, that's going to give me a 9. Still over 5. So y equals 9/5. So my other point is 12 over 5 and then 9 over 5. And those are my two solutions. Alright, In our next system, you'll see we have a b and a t sub d. So that's two equations with two variables, and what I'm going to do is use elimination, because from the start I see that I have this plus 5t sub d and then minus 5t sub d. So if I simply add these equations together, those two cancel. So I'd have b, or 2b t sub d. I'm just adding these together here as they are. Those two cancel, and that's equal to 40. 15 plus 25. And then we'll divide both sides by 2. So b times t sub d equals 20. Then we can take this 20 and put it in place of either equation for that b t sub d. So I'm going to use the first equation and say 20 plus 5 t sub d equals 25. Then I'll subtract 20 and have 5 t sub d equals 5. Then divide both sides by 5, so t sub d equals 1. Now that I know that t sub d equals 1, I can put that in here to find out what b is. So b times 1 equals 20, so b equals 20. So I have t sub d and b. So I've got both variables. Now some of these can be a little bit complicated, but at this point most of them will turn out very nicely in the book that we have. Hopefully this process helps. If you have any questions, feel free to ask.